This example is to solve an integral using trigonometric substitution. We have the integral x squared minus 9 under a root over 4x to the fourth. The square root indicates to us that trigonometric substitution should work. X squared minus 9 fits this form, a function squared minus a constant squared, which means the substitution we're going to make is u equal to a secant theta, and then this identity will help us eliminate the root. So we're going to say x is equal to 3 secant theta, which means dx is equal to 3 secant theta d theta, or secant theta tan theta d theta. That's the derivative of secant. So we have x and dx, we can substitute those in. We'll just take the x squared minus 9 under the root over here and simplify it first. That gives us x squared is 3 squared is 9 secant squared theta minus 9. We're going to factor out the 9. I'm going to write it this way. We're going to take out the 9, and that leaves us secant squared theta minus 1 in the root, and a 9 under a root outside. Root of 9 is 3. Secant squared theta minus 1, well, that's tan squared, so the square root of tan squared is just tan. So there's what this part is equal to. Let's just make a little less work over here now. That gives us the integral of 3 tan theta over x to the 4 is here, so this is x, this to the power of 4, 3 to the 4 is 81, secant to the 4 of theta, multiplied by dx, which is here, so that's 3 secant theta tan theta d theta. A secant is going to cancel here, leaving 3 in the denominator. 3 and 3 gives 9, which cancels with 81 to leave 9. So we end up with the integral, tan and tan is tan squared theta over secant cubed theta d theta. So the trig substitution has done what it's supposed to do. It's gotten rid of the root for us and given us a different integral in the trigonometric form that we now can try to solve. This is a mixed integral because it's got a division of a tan and a secant, so we're going to change everything to sine and cosine as probably the quickest option to get a solution. Not the only option, but likely the quickest. So tan squared is sine squared theta over cosine squared theta. 1 over secant cubed is cosine cubed theta d theta. Cosine cubed cancels with cosine squared to leave a cosine. So we have sine squared multiplied by cosine. So we're going to say u is equal to sine theta, means du is equal to cosine theta d theta. And if we make that substitution, then we get the integral of u squared du. Oh, we left the 1 over 9, so we should keep that the whole way. And integrating that then gives us u to the 3 over 3. U is sine, so we get sine cubed of theta over 9 times 3 is 27 plus a constant. Now, we've integrated, but we have an integral now in terms of theta when our question is in terms of x. So now we have to draw a reference triangle to replace sine theta with whatever it's equal to with respect to x, or in terms of x. So we draw a triangle, trigonometry, so we have a right angle, there's theta, and we know that secant of theta is x over 3, okay, because that's what we defined here. So secant is adjacent over hypotenuse is cosine, so hypotenuse over adjacent is secant, so hypotenuse is x, adjacent is 3. Using Pythagorean theorem, we can find that this side is the square root of x squared minus 9, which was in our question to begin with. So the sine of theta then, based on this triangle, is going to be opposite over hypotenuse, which is x. That's cubed, so if we replace it now, we get the square root of x squared minus 9 cubed over 27x cubed plus a constant. So just to quickly summarize, when you're doing trigonometric substitution questions, you're trying to get rid of the square root. So you choose the form that it fits, pick the appropriate substitution. So in this case, it fit the secant substitution. Make the substitution, take the derivative, work out the root by itself. That gives us 3 tan theta after using the identity. We put all the pieces in, so there's the root, replace x, so it's to the power 4, replace dx, so we get that. Cancel everything we can to get it in the simplest form, and then figure out a way to solve this integral. So in this case, we changed it to sine and cosine, use substitution, integrated, then we have it in terms of theta, draw your reference triangle, figure out what the trig function you have left is in terms of x, substitute to get your final answer.